welcome. So my name is Michael Arjona. I'm the head of the upper school and also the assistant head of school for academics here at the Walker School. I want to thank you for spending part of your evening joining me to learn a little bit more about our STEM program and at the first in our series of Warm Up to Walker. So the first thing I'd like to do is share a little bit of information to make sure that I'm going to share my screen here so you can see this is the lineup of events that we have. It's going to touch upon lots of different areas of the school, and different ones will focus on different divisions. So this one, of course, is going to be about STEM and the Walker difference. We'll then have some parent voices, student voices a little bit later next week, which is the next one. I hope you join us on December 16th, 1 week from today at 5 p.m. for a discussion about the value of a Walker education. We'll have a talk from our head of school, Jack Hall. Then myself and the other division heads will be here to answer some questions and do a Q&A there. And then we have some things that are a little bit more broad about what to know before making a school decision, things about athletics, arts, and clubs, and then even later things that are more focused on some different divisions like the lower school. So for today's topic, we're going to be talking a little bit about STEM. And we had the great fortune to bring some of our STEM faculty together to talk specifically about how our program works, some of the programs that we offer, as well as then some alumni who are involved in some terrific things in their career or in college to talk a little bit about the difference that it made for them and a little bit about their experience in Walker STEM program. So as you'll hear, it's going to be upper school department chairs and faculty talking, as well as then the alumni who have the most recent experience at the upper school. But I think one of the important points is that the things that they bring up are philosophies that run through our entire program. Our teachers work together across the divisions. We have vertical team meetings where we have primary school teachers in one subject all the way up through upper school teachers that are meeting multiple times a year to discuss and align philosophies. A number of our department chairs, Emily Adams, who you'll see featured, and Christy LeBron, who you'll see featured as well, are department chairs over our middle and upper school programs. So some of the things you might hear about in activities are specific to upper school, but they really apply philosophically to everything that's happening, not just in upper school, but at middle school with Mr. Evangelista's earth science class, or Kevin Tilley's physical science class, or with Dr. Martin or Miss Morris in the lower school, and then even with Miss Whittingham in the science program, as well as our math faculty across everyone from Mr. McElhaney to Miss Bachniak, and those that are able to get together and work together in that way. And that I've had the great fortune not only as working with them as colleagues, but seeing my daughter come through the program as she's now in middle school. So with that, I'm going to share a little bit of the program that we had with those faculty members and those alumni so that you guys will get the benefit of hearing it as well. And then what we'll do, if you have any questions that come up around STEM or really about anything, feel free to enter them in the chat or the Q&A. And at the conclusion of the video, then I'll certainly be able to engage in a Q&A there as well. My apologies, the sound didn't come across. If I redo the share, I think we'll be in better shape. Welcome, everyone. I appreciate you spending a bit of your Tuesday evening with us. I'm Michael Arjona. I'm the head of upper school here at Walker. And I'm going to quickly turn it over to the people that you're here to hear from. We're going to start by getting an overview of the science, technology, and math offerings within the upper school. It's not meant to be exhaustive of everything and all aspects, but just a little bit of an introduction. Then we'll have a panel of some of the upper school STEM teachers that will talk a little bit about how those classes work in the upper school. And then we have some alumni who have joined us, and that's the great thing about doing it over Zoom is they're all from different locations joining us to share some of their wisdom and experience as well. All right, so with that, I'll turn it over to Emily Adams, our science department chair.
Thank you, Michael. So I really quickly want to talk to you about some of the things that I really value about the science department at Walker, and I think some things that make us a really special place. So first off, everyone on our faculty has it in their DNA that all students can learn science. All students can be scientists, and no matter whether they want to be a lawyer when they grow up or they want to go into communications or economics, we want them to be able to look at the world with skepticism, with a critical eye for claims that are being presented, and also know the science that they need to know in order to be able to make decisions for themselves and their families once they're adults. We live this out in our mission every day by having students from the very beginning in upper school focus on inquiry, asking questions, recognizing that science is messy and it's not always linear, and that if an experiment doesn't go the way you expected, that's fine. That's how life works. It's not that you did it wrong. You just take a step back and reflect. And we teach them how to do that in all of our disciplines. We also focus on collaboration between students and faculty so that they learn how to work in a team and play a variety of roles. We also are lucky enough to have really amazing equipment at Walker, and not just students who are really passionate about science get to use the real high-tech bio equipment, but all of our students do. They all get to do PCR and electrophoresis. We're working on doing some DNA sequencing in our research class. So we want our students to have experience with that so that when they get to college, they're already prepared and they know how to use those skills. We also focus on a lot of feedback with our students on a very regular basis and mentoring. We have such great class sizes that we're able to do that as our students are working on labs in the moment. And we focus on communication. If we have great scientific knowledge, but we can't share it with our community, how much is it going to improve the world around us? So from the very beginning, we are focusing on students communicating visually, orally, and in writing to a variety of stakeholder audiences, whether that's our environmental science class, working with local government officials, or our chemistry students studying the biochemistry of COVID and proposing solutions that then they share with scientists, or even in our guided scientific research classes where students submit their work for publication to journals and competition. You can see on this next slide our current course offerings. And the two things I want to point out is that we have a wide variety of options. So students can test the waters in a lot of different areas. If they think they want to be a forensic scientist, they can take forensics. If they've always loved whales, they can study marine biology. And we have challenge at every level, no matter what students are looking for. The last thing I want to mention is two programs that I'm very, very proud of are our two science and engineering concentrations. These are kind of like mini major experiences for students to explore either public health or engineering at a very deep level. We have students taking foundational classes here at Walker with myself and Dr. Brady, and then completing a summer internship at either the CDC or at a local university or engineering institution. And I think you'll hear that from some of our alumni. And then they go on to complete the guided scientific research class in a public health or engineering related field. So that is our science department in a nutshell.
Excellent, thank you. So now Ms. LeBron will talk a little bit about our technology program. And just unmute, Ms. LeBron.
Yes, thank you. Well, thank you. Good evening. My name is Christy LeBron, and I am the Technology Department Chair. And I'm going to echo a few things from the science, since we go hand in hand a lot with the philosophy of having our kids, work collaboratively, inquiry, and communication. But our technology program focuses in really developing technically savvy students by promoting problem solving and critical thinking and the creative use of technology. And trust me, kids can be very creative with the technology. We foster the art of the possible. We want to encourage students to think outside the box and take risk and try something new. We want them to explore and not be afraid of making mistakes. And just like Emily said, it's okay. A robot will break. It will not satisfy a mission that needs to accomplish. And it's just a matter of keep trying. Our upper school program, and I do not know if Emily, can you switch to the next slide? The upper school program builds upon the curriculum that we started in the middle school, and we do have a wide range of offerings for students as well. And we really want them to test and try whatever it interests them, but we also want to encourage them to try something that they might have not tried before. And I'll tell you about a little story in a minute. But if kids want to try, there's some kids that really enjoy the media technology, the film and video and graphic design, and they have opportunities to do that. We have a great studio here, our Green Studio, but also in computer science. We have increased our offerings. We start with the computer science principles, where students can really introduce them to the concepts of computer science and challenges them to really explore how computing and technology impacts the world. And in that class, we really get a lot of kids hooked and saying, wow, this is a really neat career. And we've had a couple of juniors taking it that they wish they would have taken the class back in 9th grade because of all the other opportunities that come after that. We offer an applied programming and an AP computer science where we dig into programming in Java. And then some Arduino, some advanced topics. And I'm really excited about this one because this semester we did a focus on Arduino engineering. And I was going to try to show you, this was one of the first projects. This is our binary clock that you would have to really know binary. It shows the hours in red, the minutes in yellow. And by the way, it's 1800 is military time. So it is showing you that. And this is one of the projects that the kids just finished completing, as well as another project that I don't have it turned on, but it's a game of Snake that they developed using, again, Arduino engineering. Next semester, we'll be exploring machine learning and artificial intelligence. And if programming is not so much, but they like to build, we also have a really strong robotics program, and kids can participate either after school or during the class. We also, I'm very excited about this because we have a student technology organization that continues to grow every year, and that is offering students opportunities beyond the classroom, and they can participate not only in coding competitions and robotics competitions, but website design. And really, the sky is the limit. I have students coming to me saying, this is a topic I really want to explore. And if we don't have a class that does that, we may do an independent study course. And I've had kids in the past saying, I really want to learn about this. And we spend the semester, just digging into that topic. So again, the sky is the limit when it comes to technology. So,
excellent. Thank you, Ms. LeBron. Next is Jean Baer, our math department chair. And unmute yourself, Jean.
Hi, everyone. I am Jean Baer, and I'm chair of the mathematics department. One of the things that I think is really great about our mathematics department is that we all promote a growth mindset. having a positive attitude about learning subjects, especially ones that can be difficult, like some of the mathematics that we do, is very important. Being able to realize that mistakes are okay and that you can always grow and learn and improve what you're doing is very important, especially if you're going to be challenging yourself and stretching your mind as much as you can. Along with that, we want to develop habits of mind that are good not only for mathematics, but for all learning. We want our students to be curious. We want them to be skeptical, as Emily had said too, not just to agree with anything that's been told to them. We want them to be observant, to look around, to think, how are these things related? Are there patterns or relationships that they can figure out on their own rather than us just telling them what a formula is or how a certain pattern reacts? We also want them to develop a good dose of tenacity, because when you make a mistake, you're going to go back and try to correct it, and you might not get it right that time either. So being willing to keep working on it is also very important. And again, like has already been mentioned in the technology and science, we want our students to be able to communicate with others, because sharing ideas is a very important part of all of their learning. When challenging concepts come up, we celebrate them in our classes, and we say, hey, this is a chance for us to all learn and to grow. And if we already knew everything, it would be very boring and we wouldn't have much to do. So we work on trying to make sure that every student realizes that they have the potential to learn math at a very high level, and we encourage them to develop habits of mind that will serve them not only well in mathematics, but in all other subjects and in their life as well. Next slide, please. Thanks. We start with the lowest level that we have in the high school is Algebra 1 class, and we go all the way up through 3 courses that are beyond BC Calculus, which is one of the highest levels of math. We also offer AP Statistics, and we have a lot of availability for people in between. I think it's pretty amazing that I was looking through the list of seniors that we have this year, and 65% of our seniors are going to graduate having had some level of calculus. That's unheard of. I mean, I know there are some schools that are much larger. Even some of the magnet schools don't have that kind of statistic going in. And a big part of that is because we make mathematics accessible to everyone as much as they are willing to work on it. Again, that's one of the things I think that really sets our program apart, is that students are not locked into a track. It's not like if you take Algebra 1, you can never get to calculus. It's not easy, but there are different ways that you can manage your schedule so that if you're interested in taking calculus, we will work with you to try to make that happen.
All right, excellent. Thank you, Jean.
You're welcome.
So now we're going to do have a bit of a Q&A one with a few of the faculty members. In addition to our department chairs, will continue to join us for this. And then we'll shift into the alumni. But first, a couple of faculty members that are going to join us for this Q&A is Nate Brady and Erica True. So maybe as the first step, maybe starting with Nate and Erica and then shifting back to the department chairs, is maybe just introduce yourself, and in particular include which courses you teach within the upper school.
Sure, I'll get started. So like Michael said, I'm Nate Brady. I've been at Walker for, I guess, 7 years now. I teach lots of different physics and engineering courses, AP Physics 1, AP Physics C, Introduction to Engineering Design. I also teach the guided scientific research course along with astronomy. I get to do lots of fun things. So,
excellent. Erica?
My name is Erica True. I teach AP Statistics now and Honors Pre-Calculus, and also Multivariable Calculus and Linear Algebra. And I think I've been at Walker for about 9 or 10 years.
All right, excellent. And then going back to the department chairs, they know that you are the chair of each of these departments, but maybe first going back to Jean with which courses you teach. And you got muted again.
And I double clicked it. So anyway, I teach Honors Algebra 2 and Calculus AB.
Excellent. And Christy?
Yes, I teach robotics and the advanced topics in computer science.
Excellent. And Emily?
I teach AP Biology, Genetics, Epidemiology, and the Public Health Research class.
All right, excellent. So you see a bit of the breadth of experience and levels that these teachers teach. So maybe to get us going, maybe to start with the science teachers, Emily and Nate, when it comes to making science, learning science hands-on, what are the ways that you do that within your classes? Are there favorite examples? And, Emily, if you certainly want to talk about things outside of just the courses you teach, things across the department. But if either you and Nate want to speak to that.
Oh, sure. I'll get started with this one. One of the reasons physics is so fun is we just have some awesome toys. We're really able to do some really fun hands-on things. You said specific examples. The first unit or two, we'll get into try to analyzing position, velocity, acceleration graphs, which can get kind of technical and a little abstract. So I'll get out a motion detector, which kind of can tell the position of an object, and I'll have the student go and they'll stand in front of it, and I'll give them a graph of, say, acceleration, and I'll say, why don't you try to move in such a way that matches this acceleration plot? And so they're actually physically moving, and their lab partners are talking and debating about, how are we going to do this? What are we going to do? It really kind of connects, this more abstract kind of thought into something physical that they can really, understand and is really tangible. There's a couple other fun things that we do. Like I like to do this lab where you roll a ball off of a table, and you have to put a target on the ground to predict where it's going to land. But I only let them roll the ball off the table one time. So they have to think about it. And it's very open-ended. I say, here's the goal. You have to figure out, how are you going to do this? So they're just trying to think about what data to take. How should I do this? And then it's amazing how serious and zoned in they get and trying to figure out, because, they only get that one chance to, to get it to hit on the table. Really in physics, I really focus a lot on getting the students to be able to do the full scientific method on their own. So I love giving these kind of open-ended questions where they're the ones figuring out what data to take, how to analyze it. There's just a big difference between, solving a word problem and actually getting in there with your hands to take the data yourself. And also, just makes science really fun. So.
Excellent. Thank you.
I think just a couple of quick examples in our environmental science class. It's all hands-on all the time. Our students are all over campus, whether it's on the rooftop garden and they're growing vegetables, or, someone wanted to try growing Brussels sprouts and a lemon tree. The lemon tree was very difficult. Or we have this great, huge pond back behind our athletic facilities, and the kids go out there and they do all kinds of sampling. They look at the bacteria that live in the water, they do invertebrate sampling, and they communicate results with other schools around the country and the world, sharing what they're finding in their courses. So there's that communication piece. In forensics, my favorite activity to peek in on is the pickle autopsy, which is every bit as awesome as it sounds. They learn about how to investigate a crime scene, and they use those giant dill pickles, and they're all in various stages of not great shape. And the kids have to go in and do an investigation and predict what happened and try to explain what was going on using everything that they've learned. And I'm excited in my classes, AP Biology and Genetics are going to be doing CRISPR next week. So they're actually going to be editing the genes of bacteria and transforming them. And I never thought in a million years we'd be able to do that in a high school class. And here we are.
Awesome. Thank you. So now, and this is for any of the STEM faculty, but maybe we'll start, since we started with the science, Erica or Chrissy, Jean, if you want to jump in on this. How specifically do you prepare students for more advanced study in STEM fields in college? So, we touched upon how we're preparing all students, regardless of their level of interest. But of course, we have plenty of students that are very interested and know that they want to study this, or will end up studying this in college and will be doing so at a fairly advanced level. How do you guys ensure that you're preparing them for that level of advanced study?
Well, I think in the math department, we really concentrate on the process, and thinking are emphasized and not just the answer. And it's not all about algorithms at all. You have to have a base of knowledge that certainly is helpful, but thinking about how do you work out it and where did this idea come from and where can you go from here? Again, the aspect of developing habits of mind where you're always asking why, how, is this related to something else? Talking to other people that are in your group or trying to work through the same problem, seeing it from a different point of view, really learning to be very open-minded and think about things from a perspective that might not be your own. I think that's a very important skill.
Great.
Well, in my computer science classes, and I have a similar to what Jean has just said, but a great example, we work a lot on brainstorming, planning, thinking ahead. You know, kids tend to want to go and code right away, and I tell them, okay, let's step back and think about what the process is. And one of my students in the advanced topics, he's working on a sensor that is going to detect whether it's going the right way on the hallways, since we have directional hallways, so it's going to beep. And he was trying to figure out how to work. So we have this big whiteboards here, and we just started to flowchart the thought process of how do you think and how do you go about solving this problem. You know, don't try to solve it right away, just think through it. And once you have all the thinking and the flowchart, then you start to code and practice, and getting that skill of how to plan ahead is one of the things I really push them to do, is brainstorming.
Excellent. Thank you.
Erica, could you mention a little bit about your use of Desmos, and do you use Mathematica as well?
I do use Desmos, and I use it for curiosity and creativity purposes. So a lot of times, like today in class, we were manipulating sign functions to make things match up. And so they were kind of observing what the change in the different numbers and their positions or amplitude, phase shifts, and things like that in order to superimpose two graphs together and make them match up. So I try and like incorporate a lot of discussion, I guess, in class, and creativity and discovery in order to, I don't know, facilitate that.
And for those of us who don't know, Erica, what is Desmos?
Oh, so Desmos. Oh, how do you describe Desmos? Okay.
Like Mathematica.
It's a very exciting graphing calculator. But it's very interactive and way better. I hope nobody works for TI. Way better than TI-84 calculators. But yeah, so Desmos is it's open source, and it's just, you can actually code behind it. And it's like PowerPoint meets a graphing calculator, meets a magical mathematical tool all at once. So that's the best way.
If I could add, because Erica is too humble to say, but she also incorporates a lot of the computer science that we do in class. She, for example, finished a project where she had the kids do a 3D printing combination of, and the math part, you could explain it better, where combined the math and the computer science, and we 3D printed this wonderful cups that it just made it so real for the kids. And looking at math as an interdisciplinary, it's not just one subject. And I think looking at the connections across the board, I think that's another great way that I know Erica and the math department does.
Yeah, so that project that you're talking about, I'm happy to mention it. I just feel bad because Joseph and Carl didn't get to do that, because this particular program that we used wasn't released until 2018. So it's actually where you can take parameterized functions and build something. So I had the kids build a cup, like a goblet, and they built them through mathematical equations. And then we processed them through a program called CalPlot 3D, and it created an STL file, which is just a 3D printing file. And then we were able to actually create the goblets from those equations, which was like, it combined math and technology and art at the same time, which was like, it was a lot of fun.
Excellent. And now, and again, this one as well for any of the teachers. They're also, all three of these subjects can be challenging at times for all students. And so when there's a student who is finding a class challenging, whether it's advanced class or whether it's non-level class, no matter what it might be, what are the ways that as teachers you guys support those students? What do you do when you find a student who is struggling in your class?
In the math department, again, we kind of celebrate when those moments happen, and it's a chance to learn and to get everybody else drawn in. So making sure that we try to normalize, in calculus, in any subject, it can even be in Algebra 1, there's going to be something where you don't really understand it. It's nice to ask other kids in the class and say, well, how did you guys approach it? What do you think? And often it turns out that there's not just one person who doesn't understand that concept, that there's more than that. And then talking about it, normalizing the whole conversation, that this is how you learn. You say, I don't know how to do this. And then somebody else says, well, let's try this. Let's think about it this way. Or I don't know, what else could we do? So getting the fear away from that there's only one right way to do it, and the only way you can be smart is if you know all the answers, is key. So again, that's something that we start, right away in Algebra 1, no matter what level. We really try to go back to that growth mindset that everybody can learn. And the more questions that you can ask, the better off we are. So, and I say too, if there are no questions, I say, well, this is sad. That means you guys haven't learned anything yet today. We'll have to move on. We'll have to ask some more questions, but really trying to get them excited about learning and not thinking that math, for a lot of kids, they come in, sometimes they kind of think it's a dead subject, not quite like Latin, sorry, Devondra, but it is messy and it's vibrant, and there's more than one way to do something. And just thinking that, oh, there's an algorithm and I'm going to follow it and that's going to give me the answer. It doesn't work, and it's also very boring. So we really try to put life into mathematics, and that happens when kids start getting challenged.
Thank you.
Yeah, I agree with a lot with what Jean was saying. Physics is hard. And, in my classroom, I like to foster a lot of group discussions. We'll introduce a topic and I'll throw it out there for the students to talk amongst themselves first before we come back together. And, a lot of times the students, come up with a consensus that's not correct, and I'll throw it back to them. Okay, well, now you got to rethink this. And the whole idea is that the students aren't alone in an island with their not being able to understand something. Like, we're all there in the room together, learning together, and not knowing it right away is just part of the process. And also, like, even the more advanced students, like in the engineering research course, one of my students had this really cool idea about trying to test the air permeability of cloth face coverings to determine, is this an effective way? All these different cloths out there that people are making. Is it good or is it not? But she ran into some issues. She was trying to use an Arduino to measure this air pressure, and she ran into some problems. And so, like, I'm teaching this whole time. You're not alone. You reach out to different teachers. Talk to me. She had to learn this whole new concept about air permeability to try to solve this problem. And it's this whole idea that you're not alone. Everyone's here trying to figure this out, and that there's always someone to help.
Excellent. Great. Well, thank you very much. And what we'll do, let's shift over now to chatting with the alumni for a little bit. And then I will say, for any of you that are watching the webinar, if you have questions, either for the alumni or for the faculty, feel free to enter those into the Q&A or the chat. And then once I throw out some questions to the alumni, we'll bring up any questions that you might have, and for either the faculty or the alum. So we have 5 alumni with us here this evening, and so the first thing I'd like to do is have them just introduce themselves and maybe say a little bit about their path since Walker. Some are in college, some are in graduate school, some are out of graduate school, and so just say a little bit about sort of what's been your path and what you're doing now. So Joseph, if you want to start us out.
Hi, everyone. I'm Joseph Zuckerman. I was Walker class of 2015. Doesn't feel like 5 years ago. I did my undergrad at Harvard, graduated in May 2019. I studied electrical engineering, and now I'm in the second year of a PhD program in computer science at Columbia. My research is more on the computer hardware side of computer science. I'm really enjoying it so far.
Excellent. Thank you. Megan?
Yes. Hi, everyone. I'm Megan Beam. I graduated from Walker in 2019. And now I'm at Georgia Tech and I'm studying chemical and biomolecular engineering.
Afton?
Hi, my name is Afton Norzad. I graduated Walker in 2014, and I went to the University of Florida. I did my bachelor's in health education and behavior, and then I went straight into my master's of public health with a concentration in epidemiology. And I graduated in May and then hopped straight into an epidemiology position in South Florida. So I've been in Fort Lauderdale dealing with COVID things. So it's been an interesting year.
Yeah, I'm sure. All right. And Carl?
Hey guys, I'm Carl Lee. I graduated in 2018 and I'm currently a third year student at Johns Hopkins University. I'm studying neuroscience and applied math. And outside of my school stuff, I do a lot of research. I'm currently a research assistant for Institute of Cell Engineering at the Hopkins Hospital. And I do a lot of computational biology research for neurodegeneration, like Parkinson's disease and Alzheimer's disease. And I incorporate a lot of machine learning and AI tools.
Okay, excellent. And finally, Anna.
Hi, everyone. My name is Anna Chikala-Ritchie. Similar to Afton, I graduated in 2014 from Walker, and I went to the University of Georgia for undergrad, go Dogs, and I graduated with degree in biology and public health. And I also went straight into my Master of Public Health degree and concentrated in disaster management. So just fate of the world, perfect timing. And after graduating, luckily I found a job and I'm currently in Arlington, Virginia, where I work as a research assistant at a corporation called CNA. And most of my research or the work that I do is in FEMA's COVID response.
All right, excellent. And I'll throw this out, and whoever of the alumni would like to jump in, feel free to. And all of you chose to go into fields that are certainly challenging fields and challenging majors in college. How would you rate your preparation for those challenging fields based on your experience at Walker? And is there an aspect of your preparation that particularly stands out?
I can give a start. So Hopkins University is a research school. So a lot of students here, we do a lot of research. And my first research project that I was involved in was an extension of the guided scientific research I did for the engineering concentration at Walker, which was using a deep learning model to classify images. And I used it for medical imaging and all that. So I would say, so the toughest thing about getting into research is first, developing a inquisitive, mindset of trying to figure out why or what if type of questions. And that requires a lot of time and a lot of trials and errors. And I would say getting an exposure to that early on during high school really helped me to transition into the Hopkins style research. And also, I'd say the upper school advanced courses really helped me to develop study habits and skills. And I didn't really have to do much transition in terms of study habits when I started taking college classes.
Yeah, thank you.
My short answer is extremely prepared. But several things stand out to me. First, there's the flexibility if you want at Walker to, almost take a full first year of college, pretty much worth of material. So you're going in, you've seen a lot of this stuff before, and the teachers presented at a college level. So the next time around, or it's easier, or you're able to start at an even deeper level in the curriculum. Beyond that, especially writing skills, communication skills, which you may not think about in STEM fields, but Walker produces great writers, great communicators. And then also, to echo what Carl said, time management, taking hard classes at Walker and, in being involved in a lot of extracurriculars, being able to manage your time in college is nothing new.
Excellent. Thank you. All right, we can move on to the next question. Now, is there and I think this builds a bit off of what Joseph was just saying about things like the writing communication skills. Is there a class or an activity? We're talking about your preparation within STEM, but was there a class or an activity that you did at Walker that was outside of your field that really informed your career, your college path, beyond what you might have taken within the STEM classes?
I'll go ahead and give a shout out to Magister Randy Fields in the Latin department at Walker. I took Latin from pre-Latin in 7th grade through AP as a senior. So over that time, I learned more than any one person could ever know about Latin, about its history, the culture, the language. And in that time, I was able to develop a relationship with my teachers, with Mr. Fields, and learn not just, okay, we're going to translate Latin today, but really just learning about how, I guess, that type of learning can apply to other fields like the sciences and other classes that I took. It's a way of, I guess, applying information in some new and different way, even though it might be seen as a dead language. I think there are very real and living applications to a lot of what I learned. And I think just through learning Latin, I learned more about just, living in philosophy and the human experience. And I really appreciated the many years I took Latin at Walker.
Great, excellent. Who else would like to jump in on that?
So I'm not sure if really oh wait.
Go ahead, Carl, and then Joseph can go after that.
Okay. I'm not sure if this course really influenced my career path, but the writing classes I took, AP Literature and AP Lang, they really helped me to develop set of skills for writing and exposition. And in the field of research, so when I'm working on writing a publication or a grant proposal, you need to make a very persuasive writing to make sure that you get the funding, or you make state the significance of your research really well. And personally, I kind of thought back to the classes I took. It was really helpful in that one. Yeah.
Great. And Joseph, now if you want to jump in.
Yeah, I was going to talk a little bit about, I was involved in student government at Walker, and, just working with a bunch of other people across different grades on pretty big projects. It gets you ready for, group projects in college, learning how to communicate, split up tasks, work effectively in teams, and, overcome conflicts and stuff like that.
Great. And a next question, what is it that you think in your experience now that you have either some distance from college, maybe no classmates that attended other high schools, whether it might have been magnet schools or other independent schools, and you also have some distance from your experience here. What do you think that sets Walker apart from other options for students that are interested in STEM? And again, whoever wants to jump in.
I can start off. I know this is a question I love to answer. Super passionate about it. I think the student-teacher relations here at Walker are unmatched. When I talk to friends that went to different schools, they kind of can't wrap their head around the fact that I was friends with my teachers, that I stayed at Walker till 1 a.m. tying carnations with Mr. Fields, and I think that within itself, along with the support network, from faculty. I know when I was doing my guided scientific research, I had a lot of faculty participate. I can't disclose who, but some of them are on the call. And just to give you an idea, it was pretty comparable to a COVID nose swab. So I was very grateful that they elected to take part in that. And even with my research, I know Miss Adams would stay with me at school till 6 p.m., until she had to leave. And then another teacher would come in because I was jumping through a bunch of loopholes with that. And I think that whole support, everyone wants you to succeed. Everyone's looking out for you. And just the preparation in general, I think sets you apart. I know when I met with a faculty mentor here at Tech the other week, and we were looking over my resume, and he was floored with the fact that I had already interned at the CDC during high school, which I think is pretty unheard of. I think that's very unique to Walker. Already participated in research, and like Miss Adams even mentioned earlier, working with certain materials and processes that are typically at a university level is very, very cool. And I think why Walker definitely stands out.
Excellent, thank you.
One thing that Ms. Bayer was talking about was kind of developing more critical reasoning skills rather than just math being a sequence of steps and formulas. And definitely in college, I felt like I had a very high level of like mathematical maturity and, critical thinking and trying to really understand everything that we're doing and not just following a formula. And that, I think, set me up to do really well on like exams in college, because a lot of my exams, you get questions that you've never seen before. And if you're just following a formula that you've memorized, you're gonna not do very well. But if you really like took the time through your studying and the homeworks to understand every step and not skip anything that you didn't fully get, if that really sets you up to do well on kinds of problems that you've never seen before.
Great.
Yeah, also jump into this question. In fact, I actually talked about this with my roommates a year ago about talking about different high school curriculums and how that influenced our university curriculum experience and all that. And what Megan said about the student-teacher interaction, that is, I cannot agree enough on that. That is one of the excellent aspects of Walker culture. And the Joseph's point on the importance of quantitative critical mindset that gets developed in the Walker's upper level classes. Just adding more to that. So what I found out was that many of the other peers that come from independent schools or magnet schools, most of them, they don't have the advanced level of course offerings. For example, in math department, the multivariable calculus, linear algebra, or the advanced topics that cover more of the sophomore or introductory level of the university courses, they're not offered. Or if offered, they're offered through in a sense of attending community college classes or local college classes. The best thing I'd say is that Walker offers those college level classes, not as a college classes, but as a college level classes in the high school environment. The difference is that in college classes, those are introductory or usually introductory level or sophomore classes, and they're extremely fast paced. They assume you know how to study all this stuff, how to think properly, and they're typically prerequisite classes, so they don't care about students learning. Whereas at the Walker, when we were studying the college level classes on that one, you get to focus on actually digesting the material properly and with the excellent student-teacher ratio and all that. And when I actually retook those courses at college, I realized that while a lot of peers were having just trouble following advanced abstract concepts, I kind of remembered all the classes I took on the advanced math courses, and that's when I realized this is the difference that I observed, and something I discussed with my friends as well. Yeah.
Great, thank you. And then to
can I add one more thing?
Oh yeah, go ahead, go for it.
I think Walker, you also have a lot of opportunity to explore a lot of things, both academically and extracurricularly, and you don't have to focus on one activity. You can play sports and do robotics and be involved in Latin club and all these things simultaneously, and you don't have to choose. And I don't think you should have to choose in high school. And because it's so small, you're able, Walker, you're able to be involved in a lot of different things, and learn from a lot of your different peers and teachers, and figure out really what you love, but also build skills from a lot of different fields.
Absolutely, thank you. All right, so then now a last question to close it out for the alumni. What advice do you have for students that are entering high school? If you think back to your 8th grade selves, that when you were entering high school, and what advice you might have for students who are coming in and saying, you know what, I'm very interested in science or technology or math. So Afton, you want to start us out with what advice you would provide?
Sure. Well, I came from a super small school in Cobb County. So coming to Walker was kind of like a culture shock, which is crazy looking back. But I think the biggest piece of advice is not to be intimidated by some of these classes. I was by no means a straight A student. I struggled a lot. I didn't, excel at things at first or in some classes at all. But teachers, they really do spend the time with you. I think class size directly correlates with that. They have the time, and there's not like there's 30 kids in a class or 40 kids in a class, so they can really kind of work one-on-one with you. So
excellent. Great. Who else would like to provide their advice?
Go ahead, Megan. I would say, to echo what Afton said, explore different fields and classes that you may not think to take, but also when you find something that really, sparks that passion, like run with it. Look for opportunities to keep advancing yourself in that field or whatever it is. The Walker faculty will support you on that 100%. They can refer you to other resources, and even if it involves going outside of Walker, keep running with that thing that you find, I would say.
All right, go for it, Megan.
Yeah, I was just kind of going to go towards Joseph's point, but I guess capitalize on any little bit of passion you have, and try everything. I know there's a lot of things that I wish I had more time, that I could have fit it all in while I was at Walker to explore. Because I think one thing that's really resonated tonight, you could even see in the presentation, is how they really promote like asking questions. And if you have that love of learning and wanting to know more, the community here is really going to support that. Regardless of what you're passionate about, there's going to be someone that can kind of guide you towards that outlet to explore that more. So I'd say, guess what Joseph was saying, to kind of take any passion you have and run with it.
Excellent. Anna, what would you say?
Just reiterating what a lot of people, what they had previously said. One, just keep asking why and all of the interrogative questions, but there's something to learn every day. And I think, the curriculum, the faculty, just everything about Walker, and it makes me want to coming back here now, I guess 7 or 8 years later. Like it's so amazing what is being done every day. So I guess one would be ask why to any question. Another thing, which I think Joseph touched on a lot, is just explore every opportunity, because there's so much that Walker's offering, but even beyond Walker. And if there's something that you want to do, I'm fully confident that the faculty at Walker will find a way to make that happen because they care that much. And I think that's one of the best parts about Walker. And then I guess the final piece is just, if you see a problem in the world, you will be you are the future. You coming into high school, you're the ones that are going to be the ones to change it. And I think really accepting that and like holding your own in the world is an important lesson to learn. And if you can learn it early, you can make the world a better place.
All right, awesome. There was a question that came in actually for the faculty members, so anybody who wants to chime in, because I actually think the alumni addressed part of this. The question was, a lot of these areas within STEM require, managing stakeholders and presenting information. How do the courses focus on presenting complex ideas in simple terms? Because a lot of times that can be the difficult part, is you have an idea, but getting people to support your ideas when it's in a fairly technical field. So I don't know if any of the teachers want to speak to how that happens in any of their classes.
I would love to. And also, anybody else need these? I'll have a good happy cry later, but just to alumni like those of you who are on the screen, I am just so proud of you every day. You are amazing human beings and you are the future. And I have confidence that the world is going to be a better place because you are our boots on the ground in all of these different ways. Some, especially literally those public health boots on the ground, helping protect the health of future generations, building the tools that we need. So thank you for what you do. I think all of our courses really focus on not only the teachers communicating ideas that are complex in ways that our students can understand. We have a lot of tools in our toolbox. We have a lot of strategies, and we know the same strategy might not work for every student. But even more importantly, teaching our kids to communicate that. I know Carl spoke to that, with grant proposals. Certainly, Afton and Anna's roles in public health, you've got to be able to communicate those ideas. We start from the beginning. In biology, kids have to work in teams to make a pitch to promote a solution for antibiotic resistance, and they have to compete for who's going to be successful because we know finances are limited. So how are you going to communicate this complicated idea to an audience that's intelligent but might not be scientifically literate and get your point across and influence their behavior? In epidemiology, we worked on making websites about the economics and genetics and epi of COVID as it was evolving. How do you communicate this to a world that needs high quality information in a way that is manageable? Our physics students sometimes go down and teach our middle school and lower school students, and you can't communicate that unless you've lived it and practiced it and talked through all of the strategies that we're doing. And I will just make a pitch for great online collaborative tools. We teach kids to plow their way through primary research articles, to not be intimidated by it, so that when they get to college, they know how to tackle it, they know how to talk about it, and they have the confidence that they can understand those ideas.
All right, excellent. Thank you, Emily. So I know I've gone sort of blown right past the half hour. All right, I'm going to come back. Present day me is going to come back and replace a week ago me as we had run that panel session. I hope you enjoyed hearing from the faculty, our STEM faculty, and some of our alumni that shared their experiences and both at Walker and now what they're doing. It's really exciting stuff. I'm happy if there are any questions that anyone has. For me about our STEM programs, the curriculum, or about how we build these programs, then I'm happy to take them now. But otherwise, I hope you enjoyed hearing about how our faculty engage our students, and how the alumni are then applying that knowledge now. All right. Well, I will say I thank you for sticking around, for our full hour here to learn a little bit about STEM and a little bit about our program. Oh, I see a question here has come in. And in terms and about discussion about how STEM learning takes place in the lower school. Absolutely. So as you can tell that, a little bit of what I was saying earlier is that it really, there's a lot of connections across the board. And we have a session that's a little bit later that's going to be exclusively focused on lower school and the programs within that, within that division. And that will be coming up a little bit later in the series. All right, and thank you very much for joining us, and for the and I think we might have had. Okay, good. I think we're good on the question. So again, thank you very much for joining us. Feel free at any point to reach out if you have additional questions. Hope to see you at some of the later sessions as we delve into the different aspects over the course of the next several weeks. Thank you very much and have a great evening.